Hello, welcome once again on our lesson on limit of functions under calculus. Today we are going to continue with where we started from. Alright, and we are going to look at limits of rational functions. Okay, rational function. That is what we are going to consider today. Alright, we have considered limit of some functions. Okay, today we are going to look at a rational function, its limits. Okay, we know that a rational number, let me talk about rational number is in this form. Okay, a on b, where we are saying that the b should not be equal to 0. Alright, so this is in the form of a rational function. Okay, where a rational, or this is in the form of a rational number. Okay, and the rational number is in this form, and then the denominator, it says, should not be equal to 0. Because anytime the denominator is 0, then what happens? The rational number becomes undefined. Alright, or both shouldn't be 0. Okay, so in terms of function, if I have f of x divided by g of x, okay, in terms of function, then a rational function can also be in this form. Alright, if a rational function is in this form, then f of a by g of s, then we can say that g of s should not also be equal to what? Should not be equal to 0. Alright, so if we also have a function, a rational function in this form, then what we are also saying is that then g of s, the denominator, this functional denominator, should also not be equal to what? Should also not be equal to 0. That is what we are talking about. So if you are finding a limit of a rational function, let's see how it will be. With a limit of a rational function, let me say I have limit of rational function f of x divided by g of s, where s, let's say, approaches a. Okay, so let me say this is the limit of my rational functions. Okay, f of s and g of s. So here, if the limit of the rational function f of s over g of s, where s approaches a, then the limit of the function, okay, g of x should not be equal to 0. Okay, so the limit of this particular function here, g of s, should not be equal to 0. So when we take the, as s approaches a, when we substitute into the function of g, alright, the value here at the denominator shouldn't give me what? It shouldn't give me 0. That is what we are. So that the entire denominator will not become 0. Because if the denominator becomes 0, it makes the limit of the entire rational functions to be what? To be undefined. Or both should not be equal to what? Both should not be equal to 0. So why we are saying that, then the limit of the function g of s as s approaching a should not be equal to what? Should not be equal to 0. Or both should not be equal to 0. So we are going to give example under this, where we have two functions, one as in the form of rational, one as numerator, one as a denominator, and then we find the limit of the function. Okay, so let's look at the examples. Evaluate the following. A, limit of s squared minus 1, all divided by s minus 1 as s approaches 1. So we are taking them one by one. So let's start with the A. Okay, so we have lim s approaches 1, s squared minus 1 all over s minus 1. Okay, so if I look at the limit of this rational function here, s is approaching 1. So if I want to find the limit, I'll substitute s into the function. Alright, so if I have to check is the denominator, so that the limit of the function does not become undefined. So the denominator here is what? Is s minus 1. So it means that if I substitute x here, 1 minus 1 will give me 0. It means the denominator will be 0, which will make the function undefined. Alright, so what I have to make sure is that the limit shouldn't be undefined. Okay, so I have to check the numerator and the denominator. If I can factorize, and then one can be a factor of the other, and I cancel out and get a rational or real number for the limit. Okay, So if I look at s squared minus 1, it's the same as s plus 1, s minus 1, so that I can cancel the denominator. So you factorize and go on with that. So I'll have limit of s approaches 1, s plus 1, s minus 1. This is the difference of two squares, all divided by s minus 1. Okay, so s squared minus 1 is the same as s plus 1, s minus 1. So that s minus 1 will take off s minus 1. Then I'll have the limit of x approaches 1. I'll have x plus 1. Okay, then now I can get a real number. So as s approaches 1, what do I have here? 1 plus 1, and that will give me 2. So I substitute 1 here. I have 1 plus 1, and that is 2. So it means that the limit of the function s squared minus 1 all divided by s minus 1 as s approaches 1 is 2. Okay, let's go to the next one. B. The B will be the same approach. All right. You have the limit of the function as s approaches 2, s minus 2, and then s squared minus 4. Okay. So this also, if I substitute 2 here, 2 squared will give me 4. 4 minus 4 is 0. It will be undefined. So I'll factorize. I can factorize the denominator. S squared minus 4 is the same as s plus 2, s minus 2. Difference of 2 squared, because 4 is 2 squared. Okay. So I'll have the limit of as s approaches 2, s minus 2, all divided by s plus 2, x minus 2. Okay. Then s minus 2 cancel s minus 2, so here will be 1. So I have the limit of as s approaches 2, 1 over s plus 2. Okay, so this is what I have. 1 over s plus 2. And that will be, I'll do my substitution, and that will be equal to 1 over, what is 2? What is x? S is 2, so 2 plus 2. And I have 1 over 4. So the limit of the function s minus 2 over s squared minus 4 is what? Is 1 over 4. You make sure you factorize. You can factorize the denominator s plus 2, s minus 2. This will cancel this. Let me s plus 2. So here will be 1 over s plus 2, and you substitute 2, and you get 1 over 4. All right. Then let me go to the C. So I have the limit of the function as s approaches 2, s exponent 4 minus 16 divided by s squared minus 4. Okay, so you see that this, we have s exponent 4 here minus 16, and then s exponent 2 minus 4. Okay, when you multiply here, because here is minus and this is what? This is 16. Okay, it's a perfect square. Okay, it's a perfect number. So s exponent 4 can be the same as s exponent 2 plus 4, s exponent 2 minus 4, and that will give me what? When I expand, it will give me s exponent 4 minus 16. So what I'm saying, that s exponent 1 can give us s exponent 2 plus 4, then s exponent 2 minus 4. So that when we expand, okay, so s times x, s squared times x will give me s exponent 4. S times minus 4 give me minus 4s squared. 4 times this plus 4s squared. And then 4 times minus 4 give minus 16. So this will cancel, and you see I'm getting my answer. Alright. This can give us the limit of, as s approaches 2, s exponent 2 plus 4, s exponent 2 minus 4, all divided by s exponent 2 minus 4. So that this s exponent 2 minus 4 can cancel s exponent 2 minus 4. Then I have what? The limit of the function s squared plus 4 as s approaches 2. And that will give me what? I'll substitute 2, so I'll have 2 squared plus 4. What is 2 squared? That is 4. 4 plus 4. That will give me 8. Okay, so the limit of the function s exponent 4 minus 16 all divided by s squared minus 4 is equal to 8. Okay, it's equal to 8. Let's continue with the rest. D. So the D is we have to evaluate the limit of the function 3s. The limit as s approaches on the function 3s squared minus 5s plus 2 all divided by s squared minus 1. Okay, so before there is a rational, as you are doing rational function, before you do your you substitute the value of the x into the function, check if the denominator will not give you 0. So 1 squared is 1 minus 1 is 0. Okay, so it means you have to factorize. Okay, so if you can get a common factor. So let's see, this is what a quadratic trinomial. So let's see how we factorize the quadratic. You take the coefficient of the x, which is 3 times 2. 3 2 is 6. Then the two factors of this 6, that will give me negative 5. I think that will be negative 2 and then negative 3. Now negative 2 times negative 3 will give me positive 6. Negative 2 plus negative 3 will be negative 5. And this one, you can use the calculator. Okay, our scientific calculator you can get this on our scientific calculator. As time goes on, I'll go through how the calculator is being used for factorization of quadratic trinomial and then simultaneous equation. All right, so we can factorize the numerator as what we have the limit of s approaches 1. So our numerator, since we have negative 2, all right, so that will be giving what s minus 2, then negative 3 here, s minus 3. But please take note, you are not done. Okay, you have to check the coefficient of what? The coefficient of the s square. If with these short ways of factorizing, if you look at my lesson on factorization, I have taught that. So check if you want to use this short way, okay, as you get the two factors that will multiply to be 6, but when you add to give the coefficient of the s. One, if you want to write it like this, check the coefficient of the s, it is 3. So it means that you have to divide here by 3 and divide here by 3. Okay, so that when I divide here, become s minus 2 over 3, and this become what? S minus 3 over 3 is 1, so s minus 1. But if you are writing, to put it in a nice way, if you have what? A fraction, take the denominator and multiply by the s, so they become 3s minus 2. So that here will be 3x minus 2, and then here, since we are getting a whole number as 1, so here will also give us 3x minus 1, and then this is also s squared minus 1, which is difference of 2 squares, so we can get s plus 1. And then s minus 1. Okay, so check, you see the numerator, when you multiply 3s times s will give me 3s squared. 3s times minus 1 will give me minus 3x. And then minus 2 times x will give me minus 2s. That will give me the negative 5s. This is, and that is here. And then minus 2 times minus 1 will give me positive 2. That will give me this. Alright. So it means that our factorization is correct. Then what do you do now? X minus 1 will cancel x minus 1. So that we have what? The limit of the function as s approaches 1, 3x minus 2, and then x plus 1. Okay, I think we can continue from here. So now we substitute the 1. So we have three times 1 minus 2, all divided by 1 plus 1. Alright, so we substitute 1 here. 3 times 1 minus, so 3 1 3 minus 2 will give me 1, and then 1 plus 1 will give me 2. So the limit of the function, this function as s approaches 1 is 1 over 2. It's 1 over 2. Okay, so the e, we have the limit as s approaches 1 minus x, and then s squared minus 3s plus 2. Okay. So we have this. Okay, so let's see if we substitute 1, what is going to happen. 1 here, if I put 1 here, the denominator will be 0, but that is not a problem. Let me check the denominator. 1 square will give me 1, minus 3 times 1 will give me 3, and then plus 2. So 1 minus 3 is minus 2 plus 2 will give me 0. So there is a problem. The denominator will be 0 when I substitute the value 1. So it means I have to factorize, okay? And then if I factorize, I'll see if I can cancel out the common factors. Okay. So I have the limit as s approaches 1 minus x over. So let me do the factorization of this. So the coefficient of the x is 1 times 2. That will give me 2. Then 2 factors when you multiply. Also 2 factors when you add, you get negative 3. But when you multiply, you get the 2. So minus 1 minus 2 can do the work for us. Minus 1 times minus 2 is 2. Minus 1 plus minus 2 is minus 3. So here the coefficient of the s square is 1. So that can be written as s minus 1 and then x minus 2. Okay. So x minus 1, x minus 2. So that x times s square, s times minus 2 is minus 1 times is minus 1 x. So minus 3x. Minus 1 times minus 2 give me 2. Okay. Then, what do I do now? Here is 1 minus s and here is s minus 1. So how do I? You cannot cancel this with this because they are not the same. Okay. So I have to factorize this one too, so that it will become the same as what? It will become the same as the x minus 1. And if I want to factorize, okay, I can have a factor. So 1 and x, they don't have a common factor, but their common factor can be 1. Or I can even use negative 1. Alright, so that if I use 1, it won't change the entire function here. But if I use negative 1, it will change the function, okay? Because the difference here is that here x is positive, here is negative, 1 is negative, here is positive. So I'm going to factorize negative 1 out here, so that the function will become what? The 1 minus s will become s minus 1, and I can cancel out the common factors. Okay, so see. So I'll have what? Minus 1 as my common factor. If it happens like that, this will be negative 1, and then this will be plus x, you see, all divided by x minus 1, x minus 2. So see, if I bring negative 1 out here, I haven't changed the function, no. So the function hasn't changed, because if I mean to multiply to give me the same thing, negative 1 times negative 1 give me positive 1. Negative 1 times x will give me negative x. So the function has not changed. Alright. So, but I have now gotten the bracket as well, negative 1 and x. So let me write it so that it will be the same as this. So my limit of x approaches 1, negative 1. So x minus 1. All over x minus 1, x minus 2. Okay, so I have this. Alright, so negative 1 as a common factor, x minus 1. If I use negative 1, the positive will change to negative and negative will change to positive. So that when I expand this bracket, I'll get back the same thing. Minus 1 times s, minus 1 times minus 1, positive 1. Okay, so what will happen? X minus 1 will cancel x minus 1. So that I have the limit x approaches 1, minus 1 over x minus 2. So now that I have this, I can do my substitution. So if I put minus 1 here, it won't be 0. So I have negative 1 divided by 1 minus 2. Okay, negative 1 divided by 1, and then I have negative 1 over 1 minus 2 is negative 1. So that negative will cancel negative, and my answer will give me 1. So the limit of this particular function as s approaches 1 is 1. Okay, so we are going to look at the example in a form of root or in said form. All right. Okay, let's look at this question also here. evaluate the limit of the function 9 minus x all over 3 minus square root of s as s approaches 9. So we have the limit of the function as s approaches 9 minus x over 3 minus square root of x. Alright, so if you substitute 9 at the denominator here, alright, square root of 9 will give me 3, so 3 minus 3 is 0. Okay, so what we are going to do is that we will rationalize the denominator. Okay, so that if you rationalize the denominator, I believe you can get what? You can get common factors, and then we will be able to cancel out. Okay, so that we get a real number. So if you want to rationalize the denominator, it means that we are getting rid of the root. We have to conjugate. Okay, so it will be, we multiply 2 by 3 plus root s and 3 plus root about the numerator and the denominator. Okay, so we have the limit as s approaches 9 with the function 9 minus s multiply 3 plus root x all divided by 3 minus root x multiply 3 plus root x. Okay, let's continue at this side. So when you get this, don't be in a rush to expand both the numerator and the denominator. Okay, so here try and work with the denominator, because it's the denominator that work has to be done on. Okay, so that we don't get 0. So work with the denominator and see what you get. That if you can get a factor that can cancel out what the numerator, so that we can get a value that will make the function not to be undefined. All right, so we have the limit of the function as s approaches 9 minus x, and then 3 plus root x. So now let's expand the 3 times 3 will give me 9, 3 times x will give me what? Plus 3 times root s, 3 root s, minus root s times 3, minus 3 root x, and then minus root s times root s. Root s times root s will give me x. So the negative will affect to be minus minus x. Okay, so that I have the limit as s approaches now the function 9 minus x, and then 3 plus root of x all divided by, so when I check here, minus 3 root s will cancel, minus 3 root s, so I have 9 minus x. So you can see that I have gotten a factor that is the same as another factor at the numerator, so this can cancel this. Then I have what? The limit of the function as s approaches 9, 3 plus root of x. Okay, so now where I have reached, I can substitute the value of what? The value of x. Okay, which is 9. So it will become 3 plus root of 9. And what is root of 9? That is 3. So 3 plus will give me what? Will give me 6. So my answer is 6. My answer is 6. Alright, I believe this is understood. And in our next lesson, we will do limit involving infinity. Limit involving infinity. Make sure that you go through our channel. The topics are there for us to go through, and that will help you to learn more on this channel. I'll see you again. Enjoy your day. Bye bye.